Okay, I just want to make clear some of the expectations here for this assignment. I do want you to spend a lot of time doing exercises. I would say like hour and a half a day would be reasonable to prepare for this. Of course, you don't have class, so it's pretty much just the exercises. Now here, this DMS means degrees, minutes, seconds. I would not emphasize this, but this is something that you should be able to do pretty easily. Minutes, there's 60 minutes to 1 degree, and then seconds, there's 60 seconds to 1 minute. So this is just a exercise in basic conversion. So for instance, 125 degrees in 50 minutes, that's 125 degrees and 50/60th of a degree, right? So this is just basic decimal conversions. Now what's more important are these here, these angles. Now you should know degree and radian measures by heart. I don't even need to think about these. If I see 5/6 pi, I know I can visualize in my mind right away where that is on the circle. Now how is that? Let me get my pen. Okay. So let's look at 5/6 pi, for instance. I think that Dr. Roberts had you memorize the unit circle or draw it. I want you to internalize it. Or 5/6 pi, what about this? Now when I think about the unit circle, right away, without even thinking, I know 0 is here, I know pi over 2 is here, I know pi is here, and I know 3 pi over 2 is here, and I know 2 pi is here. You already know that 2 pi r is the radius of a circle, right? So all the way around should be 2 pi. Halfway around is pi. Quarter way around is pi over 2. Now where's 5/6 pi? It's between half pi and pi, right? So it's somewhere in here. Now is it closer to pi or to pi over 2? 5/6 is closer to pi, so it's somewhere here like that, okay? Now what angle is that? We know that this is going to go in multiples of, well, what is it going to go to? Well, I know that 1/6 pi is 30 degrees, right? So I know that this angle here is 30 degrees. 30 degrees is 1/6 pi over 6, right? So this is 180 minus 30, so this 150 degrees, okay? So you know that the important angles are in multiples of 30, right? 30 degrees, and 30 degrees is pi over 6. Right, so these are the kinds of things, these are the kinds of relationships you should think about. So as I said, you don't even really need to think about, you should get to the point where you don't even really need to think about this. What about this? Minus 11 pi over 3. All right, how am I going to do this? Well, think about this. All right, again, this is kind of arithmetic, okay? 11 pi over 3. Now, what does this look like? It's minus 12 pi over 3 plus pi over 3, right? Now what's minus 12 pi over 3? That's the same as minus 4 pi. This is 2 full turns, right? All right, so that goes away. So it just becomes pi over 3. What's pi over 3? Pi over 3 is 60 degrees, okay? So you should be able to make reasons like this. And 15 pi over 4, same thing. That's pi over 4 less than 16 pi over 4. 16 pi over 4 is the same as 4 pi, right? So this is actually pi over 4 less than 4 pi. So it's basically 2 pi minus pi over 4, all right? So you should be able to do this kind of reasoning to get these answers very quickly, even without calculating. Degree to radian, same thing, 240 pi. Right away I can see that that's 4 times 60 degrees. What's 60 degrees? 60 degrees pi over 3. So that's 4 times pi over 3, right? So you should be able to do this kind of stuff very quickly and very easily. All right. All right, sketch the oriented arc. Here he's just asking you to draw the arc. It's really not that big a deal. T equals 6. That means that if I was looking at t equals 6, say, t equals 6. I know that 2 pi is 6.28. So t equals 6 would be somewhere like this. Oops, sorry, bad circle. Right? It would be something like this. Okay, okay. All right, so these things you should be able to do very, very easily. All right, so now you have these word problems here. Now you can reason these out intuitively, or you can use equations. Let's take a 50, for example. Okay, so let's think about this. It's good to think about the intuition of what's going on here. So let's look at 50. I'll grab this and put it here. Here we go. All right. Now, when I see a word problem, I always draw a picture because that just helps me visualize. And And then I can understand if my ideas make sense. Okay, let me just try to move that back. Sorry. All right, well, we'll just leave it there for now. All right, so there's my yo-yo, 2.25 inches in diameter, spinning at a rate of, all right, so what's going on here? Right here, let me get this out here. All right, fixed. So here we have yo-yo is 2.25 inches in diameter. What does that mean? Diameter, be careful you understand. Of course, you understand the difference between diameter and radius. So 2.25 is this distance here. And take note that this is in inches, okay? That's 2.25 inches. Okay, and you have 4,500 revolutions per minute. Okay, now that's called the frequency. Okay, all right, now 500 revolutions per minute. How far does the edge go? Well, how much distance is each revolution? We have there the distance per revolution. Now, what's the distance per revolution? That's 2 pi r. That's the same as pi times distance. Okay? Because one time around is a full circumference. So this is equal to pi times the diameter. Now, right? 2r is the radius. So this is equal to pi times 2.25. Okay? All right, so what do we have? We have 4,500 times 2.25 times pi. Now, what are the units? The units are inches per minute. Okay, now we want to convert to miles per hour. So that's something else you can do. You can look up the conversion. And on the test, I would give you how many miles per inch and so on. Okay, well, 1 mile is 5,280 feet. And 1 minute is 3,600 hours. I mean, one hour is 3,600 minutes. So you should be able to do that, right? Or we can just do that whole thing out. 4,500 times 2.25 times pi. Right, 1 inch is what? It's 1 over 5,280 times 12, right? That's how many inches in a mile. So 1 inch is this much of a mile, and 1 hour is how much of a minute? 1 minute is going to be 1 over 3,600. All right, so what you're going to get here is going to be 4,500 times 2.25 times pi, and this goes on the top. Normally this goes on the top, so it's times 3,600 divided by 5,280 times 12. Now you can do some other things like the 12 cancels with a 3,600 or whatever. At this point you can use a calculator. So this is in miles per hour. Okay, so I would recommend you spend quite a bit of time on these word problems and try to get some idea about how this works. Now, the formula I used, if you want to systematize the formula, what I had is that the distance, how did I get this result? If you think about how I got this result, the distance is equal to the frequency, or I should say the distance per time, or the velocity. Let's just say it that way. Okay, so that what I used was the velocity is equal to distance per time, which is equal to revolutions per time times the distance per revolution. All right, now revolutions per time is the frequency, and the distance per revolution is going to be 2 pi r. All right, so that's the formula I used. This velocity equals frequency times 2 pi r. Now you can remember that, or you can just reason it out. Okay, so that formula will pretty much take you through the rest of these exercises. There may be another formula here or there. All right, there's one that involves area. Okay, and then here's about sectors. This one's a nice problem, 63. I recommend you look at 63. Okay, and 64 you don't need to do. That's just something that you look up. All right, so let's move on to the next section. Next section, sines and cosines. Same deal. You should be able to do these even without drawing the picture. All right, for instance, theta equals 4 pi over 3, right? Now, there's a multiple of pi over 3. Which quadrant is this in? If you think about it, it's in the third quadrant, okay? In fact, it's pi over 3 more than pi, right? So it's in the third quadrant. It's 60 degrees below the horizontal, okay? So what are the sines and the cosines? Well, it's third quadrant. They're both negative. If you think about it, since it's 60 degrees below, the sine is bigger than the cosine. Now, you know that when you have angles that are multiples of pi over 3, one value is 1/2 and one value is square root of 3 over 2. So if the sine is bigger than the cosine, then the sine should be negative square root of 3 over 2, and the cosine should be minus 1/2. Okay, so you should be able to reason these out pretty quickly. And if you look at this one, minus 43 pi over 6, right? So again, you look for the closest value, right? If you take this to minus 42 pi over 6, right? Minus 42 pi over 6, that would be minus 7 pi. All right, so it's minus 7 pi, and then it's minus another pi over 6. So in fact, that's the same as 5 pi over 6. 5 pi over 6, what's that? That's 30 degrees above 180. All right, so that means that so the value of sine and cosine are going to be, one's going to be 1/2, one's going to be square root of 3 over 2. This time it's the cosine that's bigger. Since it's in the second quadrant, the cosine is a negative, so it's minus square root of 3 over 2, and the sine is 1/2, okay? So in these quadrants here, you should be able to know these, rattle these off extremely quickly. When you're doing calculus, you can't take time to stumble over these. These are things that you need to be able to just do. Okay. Now here when they say find all angles which satisfy the given equation, you should know that for any cosine value there are two angles. All right. So you can see that, of course, if you draw the circle. If you draw the circle, you can see that if I take any value of cosine, the cosine is giving me the x value, right? So here's my unit circle. If I take one value of cosine, that would be like x here. Now there are two angles that satisfy that. There's going to be one here, and there's going to be one here. Now one's a positive angle and one's a negative angle. So this is actually theta, and this would always be 2 pi minus theta. Right? So that's the way you can get those two angles. So these have the same cosine. All right, now what about having the same sine? Well, to have the same sine, if you think about that, that has the same y coordinate here and here, right? Okay, so these have the same sine. Now, how would you relate these two? If I call this phi, what's this going to be? Well, that's pi minus phi. Okay, so those have the same angle. All right, so you can always get the answers this way. So you think about the answer. You can draw a circle; it's helpful, but the answer should come very, very quickly. Okay. All right, here's a calculator problem. This is probably useful. You want to make sure that when you compute angles, you're using either degrees or radians, and sometimes people compute the angle in radians, and they think it's in degrees. Now look here, this is sine of pi degrees, not sine of pi radians, so the answer is not 0. Okay, so you have to be careful about that. So these are in degrees, and the ones that are not in degrees are in radians, right? If there's no degrees, you assume that it's in radians. Okay. Pythagorean Theorem, this should all be very quick. This is your old SOHCAHTOA stuff. All right, you should be able to do that immediately and quickly. I don't think I need to repeat that. Okay, then you do this kind of stuff. This is all this basic common trig stuff, right? If you have angle and the hypotenuse, then you want to find the opposite, right? You know, opposite over hypotenuse is going to be sine. And then, so that means sine of 5 is equal to opposite over hypotenuse. You know the hypotenuse, you can solve for the opposite. Okay, these you should be able to do in less than 15 seconds. All right, let's see what else we got here. Equations of motion. You can look up the examples in the exercise in the chapter. Okay, very straightforward. All right, so that takes us through this problem set. Okay, section 3, let's leaf through the chapter. 6 circular functions. You should know these. Sine, cosine, secant, cosecant, tangent, cotangent. Now, the important thing is to know sine and cosine and how to express the others in terms of these two, right? Secant is 1 over cosine, cosecant is 1 over sine, tangent is sine over cosine, cotangent is cosine over sine. Remember those, okay? This should be very natural. All right, you can also think about the picture. So tangent is slope, right? So that's y over x. Sine is y, cosine is x, all right? So that should give you kind of a hint of how to do this, all right? You read through the chapter, see these things, okay? So we've got this stuff here. Let's scroll down to the next stuff, all right? All right, generalized reference angle theorem, and no matter what quadrant you're in, if you figure out what the reference angle is the angle to the x-axis, you can find the sine and cosine for that, or you can find all the functions for that, and then you just decide on the sine, SIGN, of the trig function according to the quadrant that it's in. Right? So you can read this and see, like for instance, this here, pi over 3 here, that's pi plus pi over 3, that's 4 pi over 3. The reference angle is pi over 3. So I know that the sine, for instance, of pi over 3 is square root of 3 over 2. It's in the third quadrant, so the sine of this angle is minus square root of 3 over 2. All right, so you can reason these things out. Basic identities, these are all different forms of this identity. Notice here what we have, difference of squares. Isn't that interesting? Okay, that really comes in quite a bit. Now these other ones just follow from the first one by dividing by various things. For instance, if I take this identity and divide by cosine squared, I'm going to get this identity when I rearrange. Okay, so really you only need to remember this one, but just remember you can either divide by sine squared or cosine squared to get different stuff. Okay, so a good strategy of doing this is reduce everything to sines and cosines. All right, and then once you reduce it to sines and cosines, then that's a good way to prove identities. All right, all right. And you'll see sometimes difference of squares comes in very handy. All right, so more of these different trig identities. Okay, all right. So here we've got these. This just application of the same identities. Okay, some strategies for verifying identities. Okay. All right, some other stuff, secants of angles, blah, 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 blah. Okay, let's go down to the exercises. We're going to get there. Domain and range. This is, you know that the cosine and sine have infinite domain but limited range. Okay, but the secant does not have a infinite domain because for instance, cosine of pi over 2 is a 0, so it's not going to work there. Okay, so secant and cosecant aren't defined anywhere, neither is tangent or cotangent. All right, here we go. All right, so this same thing is with cosine and sine. Be able to do this for any of the trig functions. Okay, and then here, if you know the quadrant, you can know how to do this, find the SIGNs of the trig functions from the quadrant. Now in this section, and then here again, tangent, there's going to be two angles with the same tangent. These will always have two different answers within this unit circle. All right, so we've got this kind of stuff. All right, so being able to solve triangles, standard bread and butter stuff. Okay, then here's solving word problems. You find distances, you find heights of towers, and so on. Right, so that's all bread and butter stuff. You need to be able to do that. All right, so just be very, very good at this stuff. Don't neglect this. Don't neglect practice, because you need to practice to be able to do this quickly. This is not just, oh, I know how to do that. Not good enough. You need to know how to do it well and easily. Okay. Spend a lot of time on the identities. Maybe you can work through all of these. All right. Know how to do these very well, because I'm going to make the quiz quite demanding. The quiz is next Thursday, a half hour. No, I think I may have 45 minutes. Okay, let's give you time to copy and put it in. But you will need to, if you know this stuff well, you won't have any trouble with it. All right. So this is kind of a, this is kind of, it should be very straightforward. It's just maybe a little bit time consuming, but you really need to ingrain this into your consciousness so that you can do it well for trig. And of course the answers are here, so it shouldn't be hard to check yourself. And again, please spend time, hour and a half a day doing this. You can break it up, maybe half hour here, half hour there. Spend some time doing this, and you'll do fine on the quiz next Thursday. Okay, let me know if you have any questions. You know where you can reach me. Okay, that's it.